In this video, we're going to talk about the basic limit laws. So the first law that we have is called the sum law, and all that means is that if you have the limit of the sum of two functions, that it is equal to the limits of the individual functions themselves added together. So for example, if we have the limit as x approaches 2 of x cubed plus 5x plus 7, we can actually break that up into three separate limits, like so. So we simply evaluate just by direct substitution here. So for the first limit, I plug in 2 to x cubed, and I get 8. And for the next one, I plug in 2 to the x. So I get 5 times 2, which is 10. And the limit of any constant, in this case, the limit as x approaches 2 of just 7, so there is no x to plug into. If that's ever the case, then the limit is just the value it is itself. In this case, that would just be 7. So we take all these values, we add them up together, and we get an answer of 25. So there's your first limit law. And by the way, this setup for the sum law actually works for subtraction as well. So if you ever happen to have two functions being subtracted together, you can always separate them as the difference of 2 or 3 limits, as many as you may need. The next law is the constant multiple law. The constant multiple law says that if you take the limit as x approaches c of some number or coefficient times a function, it's equal to that coefficient being multiplied by the limit of the function. So for example, I have the limit as x approaches 1 of 5x squared. So notice that I have this as my coefficient of x squared. So I can push him to the front of my limit and rewrite it. So after I rewrite it, I can go ahead and evaluate my limit. So this is still going to have the 5 there, and then the limit as x approaches 1 of x squared, I do my direct substitution. I plug in 1 for x and get 1. So this is all multiplication here. So this would be 5 times 1, because this is 5 times the limit of x squared, and my result is simply 5. The next law that we have is called the product law, and you will have to excuse the sound in the background. We have somebody mowing our yard and our dogs are barking, so I do apologize for the sound. We have the next law as our product law, and this is the limit as x approaches c of the product of two functions, and it is equal to their individual limits multiplied together. So for example, let's have the limit as x approaches 2 of x squared times the quantity x plus 1. So again, I'm going to separate this out into two different limits being multiplied together, just like so. So the first piece of that product I put into my first limit, and then that quantity x plus 1 goes into my second. So I'm going to go ahead and evaluate each of these individually. So for the first part, I have x squared, and I'm going to plug 2 into it. 2 squared is 4. And then we're going to evaluate the second one by direct substitution as well. So we plug 2 in for x and get 2 plus 1, which is 3. And these individual limits get multiplied together, giving us an overall limit of 12. The next law that we have is called the quotient law. And the quotient law says that if you have the limit of a quotient, it's equal to the individual limits of those functions divided by each other. So, for example, we have the limit as x approaches 1 of x squared divided by x plus 1. So, same functions as our product law, just divided this time. So we're going to rewrite this as a quotient of the individual functions. And there is now a truck of furniture outside my house, and my dogs are barking. So again, please forgive me for the sound. So what we're going to do for this is we're going to use our direct substitution again and get our new quotient. So I'm going to take 1 and plug it into x squared, which yields a 1. And I'm going to plug 1 into x plus 1 and get a 2. Notice that this fraction is completely reduced and simplified at this point, so this would be my final answer for this particular limit. And we have one final law that we have. It's called the powers and roots law. And this is for any kind of exponent or rational exponent, or root, because roots are also exponents as well. So I'm going to show you a couple different examples for this one. One is a basic exponent and one as a root, so that you see both different kinds. So for our first example, we're going to have the limit as x approaches 2 of the square root of x cubed plus 5x plus 7. So what we're going to do first is rewrite this as an exponent, and square roots have the same exponential value as 1 over 2. So here I'm going to rewrite it just like so, and what this law tells me I can actually do is some pretty cool grouping mechanisms. So I'm going to follow this part right here in that I can actually evaluate the entire limit from here to here, and when I'm done with that, I can after that take the square root of it or raise it to the 1/2 power. It's the same thing. And if you notice, this limit as x approaches 2 of x cubed plus 5x plus 7 was actually in our first example, and we already got a result of 25. So I'm going to put the 25 in there, and then my 1/2 is on the outside. So this is now asking us, what is the square root of 25, which we know the answer to be 5. So that's all you have to do when you get square roots. So you can always do the square root at the very end after finding the limit of everything inside of it first. So here's one other example of a rational exponent. So we don't have to convert our exponent this time because it's already written for us. But we are going to regroup what we want to do first. And this is a really great property that this law has. So instead of me actually plugging in 27 first, I can actually do everything except that power first. So if I plug in 27 to x, my entire result from that single part is just 27. There's nothing else I have to do there. However, that exponent is still there, and now we have to take care of that. So in order to do a rational exponent, you can either choose to raise it to this exponent here first, and then take the cube root of it, or you can do it the other way around. In this case, since I'm going to do this mentally, I'm going to take the cube root of 27 first, since I know that the answer to that is 3. So I'm going to go ahead and do the cube root of 27 first, which is 3, and what I'm left with in my exponent is just a 2 over 1, or just 2. So now after that, I'm going to square my 3 and get a result of 9, and that is it. And that will conclude this tutorial.